Welcome to The Explainer. Today, we're going to decode the powerful universe-shaping rules of thermodynamics. Ever wonder how an engine turns simple heat into motion? Well, it's all about these fundamental rules.
The name kind of gives it away, right? It's the science of heat force, or heat, work, and energy.
Okay, first things first. We need to define our players, the system, and, well, everything else, the surroundings.
So how can we measure all this consistently? That brings us to a weirdly named rule, the zero flaw.
Basically, if system A is the same temperature as C, and system B is also the same temperature as C,
Then A and B have to be the same temperature. Sounds obvious, but that's exactly why thermometers work. All right, so we can measure energy, but what actually happens to it? This brings us to the first law.
the big rule here is you can't get something for nothing. Energy isn't created or destroyed, just changed.
So when you pump heat into a system, that energy splits. Part of it stays, and part of it goes.
Here's a simple way to think about it. The energy is like money. It's always accounted for, just spent differently.
Okay, so if energy is never lost, can we make a perfectly efficient engine? Well, this is where reality hits.
The short answer is a big no. A huge chunk of that energy is always, and I mean always, lost as waste heat.
And that's the second law in a nutshell. You can't turn all the heat into work. It's literally impossible.
And get this same rule explains refrigerators. They're basically just heat engines running in reverse.
So, these energy changes happen in a few specific ways. Let's quickly look at the 4 key processes.
Each process is a different path, defined by what's kept constant, like temperature, pressure, or volume. So these simple laws govern everything from your car to distant stars. Makes you wonder, what else are they shaping?